Hi, thank you everyone for joining today. We are having Daniela Puzzello from Indiana giving a lecture on experimental macroeconomics. Thank you, Daniela, for joining us. It's a pleasure to have you here. You can take over.
Yeah, thank you very much for giving me the opportunity to give this lecture. As Bruno mentioned, I'm going to discuss experiments in macro and monetary economics. Let me just go first through the outline of the talk. So first I will give a brief introduction to experimental methods. So why did economists conduct experiments? What are the main reasons motivating economists to conduct experiments in economics and macroeconomics? And then I'll give a brief overview of experiments in monetary economics, but I will provide some references to reviews in experimental macroeconomics. And finally, in the spirit of the proof is in the pudding, right, I will provide an application to monetary economics. And then ideally, I would have you participate in an experiment, but there is not that much time, not enough time. So I will just discuss an application and I will illustrate some of the principles that experimentalists use to guide the design and implementation of experimental frameworks. So let me start with a brief introduction to experimental methods. Experimental methods in economics date back to the 50s and 60s. And initially, they didn't really receive a warm welcome, right? It was not bed of roses. Partially because there was this idea that economics was mainly an observational science, so we would need to be just content of up and sense data, and also probably because the object of experimentation, the object of observation are not inanimate, but they're human beings who react to the experimental treatment. So it was economists were somewhat more cautious about the idea of using experiments to draw or to infer laws of behavior. And this type of skepticism is captured by these quotes. One is coming from a book, the 1985 edition by Summerson and Nordhaus, who mentioned one possible way of figuring out economic laws is by controlled experiments. So this so far, right, so good. But then they go on and write, economists, unfortunately, cannot perform the controlled experiments of chemists or biologists because they cannot easily control other important factors. Like astronomers or meteorologists, they generally must be content largely to observe. And this is true also in macroeconomics. There is a quote by Sims, economists can do very little experimentation to produce crucial data. This is particularly true of macroeconomics. And this paper actually was published in 1996. And by then, there were several experiments actually published also in prominent journals. And so the experimental methodology was already emerging. By now, this skepticism is less prominent. Experimental methods are accepted as a tool, right, in the economist toolbox. Indeed, Vernon Smith in 2002 won the Nobel Prize for the use of laboratory experiments as a tool in empirical economic analysis, in particular for the study of different market mechanisms. So the idea here is that experiments, again, are a tool that is complementary to other tools that we use in our research. And as I mentioned, it is well accepted. It has been used by other Nobel Prize winners in the research, Sultan, Kahneman, Ostrom, Al Roth, Seller, and more recently, Kremer, Banerjee and Duflo for their experimental approach to alleviating a global property. So what's the experimental method? The experimental method is a systematic scientific approach to research in which the researcher manipulates one or more variables and controls and measures any change in other variables. So that's the main idea, using experiments to better understand causal implications. And what were they used? What are they used for? Right? Why did economists were motivated to use experiments? Al Roth, in his paper "Laboratory Experimentation in Economics," discusses three broad categories and three broad reasons. Speaking to theories, that is to test and modify the economic theories. So the idea here is that theory and experiments could engage in a dialogue, back and forth dialogue, I would argue, that could enrich both sides. So basically, there are theories, propose their theories that could be potentially brought to the lab, being tested. Whenever the observed data does not conform with the prediction of the theory, this could shed light on some things that the theory doesn't capture and maybe should capture, right? And so lead to new theories so that can be tested and so on and so forth. So this would be this back and forth dialogue between theory and experiments. Other broad reason is to whisper into the ears of princes. This would be the idea, to use experiments to inform a policy-making process, and searching for facts. Another reason that is collect data to discover and document anomalies or irregularities. By the way, these categories, they're not exclusive. There is also, of course, overlap. Zooming into more details, there is Vernon Smith, right, also has a nice paper discussing experimental methodology. And again, zooming into these categories and providing more details, experiments could be used to test or select between theories, for example, thinking about also equilibrium concept, like the Nash equilibrium versus competitive equilibrium. And if you find out that the theory does not perform well, right? One can use experiments to better understand reasons why a theory might have been failing. First, trying to fix aspects of the experimental design potentially, and then if those hold, think about reasons. That was the case. A nice example in this category was is the ultimatum game, where a proposer and receiver have to share an amount. The proposer make a take it or leave it offer to the receiver, and the receiver has to accept or reject the proposal. If he accepts the proposal, the amount gets divided as proposed by the proposer. If he rejects, they both get zero. So this would be an extreme form of bargaining, a take it or leave it bargaining, where the proposer has all the bargaining power. Now, by subgame perfection, the prediction should be that the proposer proposes the lowest amount possible, right, and the receiver accepts. Of course, this was not observed in the lab. The receivers actually proposers were proposing a relatively high amount between, let's say, 40 and 50%. And of course, the question was, why is it that the notion of subgame perfection doesn't seem to be working here? And there were some conjectures. Two main conjectures were, okay, there could be some other regarding factors playing a role here. So the proposer cares about the receiver, so he splits with him, he gives him a substantial amount. But another option could have been also the fear of rejection, right? So you are afraid that if you propose a low amount, then that would get rejected. And indeed, experimentalists came up with a new game, the dictator game, that allows to disentangle, right, these motives, because with the dictator game, now the proposer makes a proposal and the receiver is really passive. He doesn't have a say. That proposal is implemented as initially proposed. And they found that in that case, of course, the proposed amounts were much lower, indicating that fear of rejection played an important role. So again, here, what I'm trying to illustrate here is that you could use experiments to answer some questions that might raise during your the exploration of some theories. On the other hand, when the theory succeeds, you can also explore, stress test the theory if you like, explore extreme portion of the parameter space to stress test the model and identify the edges of the validity. Compare different institutions, for example, different trading institutions. There are, as we know, right? We know that there are more, institutions that might be perceived as giving rise to more competitive outcomes, right? As it was the case for double auction. And they could be contrasted with other institutions like over-the-counter or Tattleman or limit order books and so on and so forth. The advantage here is, again, that while in the field you observe different institutions in different countries at different point in time for different assets, here in the lab you can control, for example, for the asset class, right? You could give the same type of asset and isolate the impact of the institution. Compare different environments. We're going to see an example today, where an environment where there is going to be money, an environment where there is no money. Establish empirical regularity as a basis for a new theory, evaluate policy proposals with the idea of pre-testing them and evaluating them in a more controlled environment. Use the lab as a test bed for institutional design, and this was the case, for example, for the Arizona Stock Exchange, but experiments have also informed different auction mechanism design. And I mean, there are reasons that arise as the economics field evolve. Here I put in parentheses added, because these are some reasons that were not in the original paper by Vernon Smith, but that are reasons that we use experiments for. In particular, for teaching purposes, it's a very nice tool. There are some nice softwares that you can use. For example, in your classrooms, they're quite easy to use. The Econ Lab, which is administered by Charlie Holt at University of Virginia, and Mob Lab as well. So there are some options. And I have used it in my classes. And indeed, I think it is easier to illustrate a certain concept. For example, in game theory, even before introducing the notion of Nash equilibrium, one can have students participate in a game. Similarly, for macro, if you care more about you know, aggregate outcome, price formation, and so on, there are markets experiments that could be implemented. So experiments can also be used to estimate parameters, degree of risk aversion, bargaining weight, and are also a valuable tool for equilibrium selection. And this is particularly important for macro, right? In many models, we do have both micro models, there are coordination models, but in macro models, there are multiple equilibria. And in some cases, theory is silent, right? It doesn't provide much guidance on which equilibrium might be more plausible or more likely to rise. And in this case, in some instances, experiments could help provide some guidance. Indeed, there is a nice quote by Lucas, which mentioned, related to the overlapping generation model. The issue involves a question concerning how collections of people behave in a specific situation. Economic theory does not resolve the question. One can imagine other principles that would, but this cannot rule out the possibility that still other principles might resolve it quite differently. It is hard to see what can advance the discussion, short of assembling a collection of people, putting them in the situation of interest, and observing what they do. So in a sense, that's something that also could be done with experiments. Of course, for macro, it is more challenging than for other approaches, right, in microeconomics, just because the models are in many cases dynamic and more complex, but there is also research showing that it's not impossible, and you do get valuable insights. They've been used in macroeconomics experiments also to test the predictions of the model, or also the assumptions of the model, whether, for example, expectations are rational or not. They are also valuable whenever the relevant field data is not available or causal inference is difficult due to endogeneity problems. As I mentioned before, to test bad policies in institutions, so one can ask questions whether policies work as intended, and if not, explore reasons why, understand whether subjects, for example, use particular heuristics when making decisions, and potentially what type. And they're also, they can also be used to explore the robustness of model predictions to play by subjects who might be boundedly rational, are non-expected utility maximizers, and have other regarding payoff concerns. Okay, so this is also, I think, an important point, because, I mean, typically we do not like to, and for good reasons, to depart from rational expectations or from more mainstream approaches. Okay, because we have stronger and more precise predictions, right? As soon as you depart from certain assumptions, you might have this anything goes type of results. However, I think that experiments could be also used, again, with this back and forth dialogue between theory and experiment, could be used to discipline some of those departures, right? So if we need to depart from certain assumptions, where do we go? Well, we could use potentially experimental data to help us guide on what departures, right, make more sense and have more support. Okay, so overall, I would say that while it is true that experimental methods, as of now, are accepted in micro and to some extent also finance. If you remember Bernard Smith, he won the Nobel Prize actually for markets, right? For markets experiment. So it is accepted, widely accepted, right? In at least micro, to some extent finance. I think they have important advantage in macro, and there is some work showing that economists are recognizing that. And this is presumably true also because of the development of micro-funded models that are easier, right, more easily implemented in the laboratory because they make explicit, right, the agents, their action set, the payoff functions, and so on and so forth, right? The development of computational methods and also online platforms. So online platforms are important because they allow to implement large-scale experiments. So for macro, in some cases, people would like to see, researchers would like to see like many agents and have doubts that a laboratory consisting of 14 students could tell us enough, right? Well, now we have through online platforms, we have the ability to reach larger, right? To implement larger scale economies, as well as also reach more representative populations. Okay, so if people are concerned about students in particular, you can reach other type of populations. So I think that again, these factors indicate that experimental methods can be a useful tool also in macroeconomics and monetary economics. So let me give you an overview of what has been done. So let me start actually with the last bullet point. I'm going to discuss what has been done in monetary economics and in models where money plays a role, so where basically money, the monetary exchange arises endogenously as an equilibrium arrangement. But before I discuss some of the contributions in the area, let me tell you that more generally for macro experiments, there are some nice reviews. So Conrad and Heinemann, Peterson et al., Duffy, Holmes provide more comprehensive reviews, and there have been experiments done on dynamic intertemporal optimization, the growth model, expectations formation, learning to forecast bank runs, and monetary policy, and so on and so forth, right? And in addition to those surveys, there are also relatively recent experiments using surveys. For example, Armentier or work by Coibion, Koronnichenko and co-authors. They just do information treatments, and they are interested, for example, in seeing how inflation expectations, whether inflation expectations can be affected, and potentially whether then one could use inflation expectation as a monetary policy tool, still a question mark. And also there are, I didn't place here because of I mean, partially because of the space, there are also experiments, field experiments in labor economics, for example, conducted by Kircher, Michel Belot, and Mueller. Okay, this is Philip Kirchler, so where they look at intervention in online labor markets. So anyway, there is an active, by now I think there is some work, right, both in experimental, laboratory experimental economics, as well as application of the experimental methods in other contexts, either field or through survey studies. Regarding monetary economics, there is also quite a bit of work. Here, as I mentioned, I'm focusing mainly on micro-funded models. So, for example, Marimon and Sander implemented overlapping generation models, Duffy and Knox, Kiyotaki Wright type of model, and then there are other with John Duffy and I, right? We implemented the Lagos Wright type of model. So these are search models on money. And what did we learn from those studies? Davis et al. I mean, all the studies listed here, right? Money indeed appears to help in the laboratory. And there are some studies, in particular, Kamera and Casari, Duffy and Puzzello and Davis et al., where they even contrast economies with money with economies without money, and they do find that the economic activity or cooperation rates, conditional on money holdings, tend to be higher when there is money. However, we'll see that the paper on the application I'm going to show you today will shed more light also on why is it that people use money in the laboratory. They've been used in the context of monetary economics also to study the coexistence of multiple currencies, and particularly in the context of multiple countries, multiple currencies, and thinking about the legal restrictions and how those might affect, or other parameters of the model might affect the status of a currency. They've been used to study monetary policy through changes in the money supply. Again, Marimon and Sander have some work, and I have some work with John Duffy and also with Janet Zhang and Kathy Zhang. For example, in my paper with John Duffy, we implemented the Friedman rule in the laboratory. So the Friedman rule, in the words of Woodford, is the most celebrated propositions in pure monetary theory, right? So can be considered the mother of all monetary policy rules. And yes, what we do in the lab, we show that you can implement such a dynamic environment. In particular, we use the Lagos and Wright model. The Friedman rule is optimal in that model, as in many other models. And the main idea is that, again, there is an opportunity cost of holding money, and policymakers should engineer a rate of return on money to compensate agents for holding money. And what we do in the lab, we implement two different versions of the Friedman rule, one through contractions of the money supply, and the other through interest payments. And we do find, actually, we do not find much support for the Friedman rule. In the paper, we go into more detail of why we think that's the case, but potentially more work might be needed to get a more conclusive answer on the optimality of the Friedman rule. But basically, it's an illustration that you despite the fact that it is that macro environments are more complex, they can be implemented in the laboratory, and they can still help us to shed light on some economic phenomena. Another thing I'm currently working on with co-authors also, again, Janet Zhang and Kathy Zhang, I think these are good environments. In general, the experimental frameworks can help to think about digital currencies. De facto, right, these currencies are digital in the lab because these are holdings that subjects, right, can just view on their computer screen. So these are just digital endowments of currencies, and one can use potentially these the laboratory or experimental methods to evaluate different design features. So for example, we're discussing paying interest on central bank digital currency or other design features of digital currencies more generally. Okay, so this is kind of concludes my overview, right, of experiments in monetary economics. Maybe I'll stop a moment just to see if there are some questions. If there are no questions, I will move on to the application.
I have one question. I don't, if you don't mind. Since it's in the introduction, I think it's a bit, how do you see the difference between lab and field experiments? How do you have a view of like what type of question you should more be thinking about the lab, and what type of question you should be thinking more about field experiments? Do you have any?
Yeah, I mean, basically there are a bit of trade-offs, right, when you do experiments. In general, I think if you, especially in cases when you would like to make policy recommendations or right, it's important that your insights are externally valid, so to speak, right, that you have external validity. Ideally, it would make sense to go to the field, even though, of course, it's not as clean as the lab, right? Because in the field, there are many things going on at the same time that might affect and create confounds in the results. That said, also for macro, but in general, I would say even for policy in general, even if, so there are two issues. In some cases, it's actually unethical, impossible, or there are really high barriers to go into the field, right? For example, if you wanted to implement a macro policy, it would be hard to go to the field, right? It's if it's something that it is not already accepted, or right, you would like to test something because you are going to have, there is the risk that you're going to have there are going to be really bad consequences, right, on the economy. But so for macro, I think it's more challenging in general, but not impossible, I wouldn't say simple, to do field experiment. But the lab, I think what's helpful about the lab or more controlled experiments is that still, even if at some point your final goal is to do it in the field, the lab could still help you to pre-test some features, right? So, and to get to isolate certain channels and see if it is at least at work in the lab. Because if it's not at work in the lab, I think it's more difficult that it would be that channel that maybe you were hypothesizing was going to work in the field. So I think in general, there are like advantages and disadvantages. My take on this is that what you should pick what you think is the best tool, right, for your question, and potentially complement, right? Couldn't go first with the lab experiments and then move it into the field and so on and so forth. But there are, I would say, advantages and disadvantages, right, in both. So I think they're complementary tools. Yeah. So I mean sometimes the way that experiments, indeed, one of the criticism is this external validity, no? The idea that, okay, whatever holds in the lab might not hold in the field. But if we really take this criticism seriously, I think this applies to the field experiments too, because whatever applies in the field, right? Typically, you do not test extensively the whole economy, right? You test, I don't know, some villages in in some country or some. So I think it's just a matter of integrating and accumulating knowledge, sufficient knowledge to get more robust insights. Okay, so I'll move now to an application. So the application actually in terms of what we see here, it's kind of circling back to more fundamental questions about money and thinking about the essentiality of money, or why money helps in laboratory economies. And I chose to present this application because it's very simple. It still provides some nice insights, and it also will allow me to, in the process of it, I will also discuss some of the principles that, again, economists use when designing and implementing experiments. So this paper, the application is a paper, is Money Essential. The title is a Money Essential and Experimental Approach, and is joined with Janet Jung, Peter Norman, Bruno Sultanon, and Randall Wright. So the question is here, and here we're going to use, you'll see, a framework that shares some features of overlapping generation and search models on money. But the question is, how is it possible, right? It's something that actually, how is it possible that nothing could amount to something? That is something that has no intrinsic value, in particular fiat money, right? An intrinsically worthless and inconvertible object. How is it possible that this could have some value, okay? Some positive value. Why is it the case that money, fiat money, is essential? This was where by essential we mean that superior outcomes are incentive feasible with money than without money. And this was actually a question that was considered for some time an embarrassment for economic theory, was solved by now. I'm going to discuss, I mean, we now know the frictions that are typically considered necessary for essentiality, but it's a question that is still open in terms of experimental evidence. Okay, in this paper, we shed light on this question. And we follow a mechanism design approach to monetary theory, described by Wallace as the search for fruitful settings or environments in which something that resembles monetary trade actually accomplishes something. So we know by now that there are the frictions, right? There are some frictions that are typically considered necessary for essentiality. The first one is very simple, is a lack of double coincidence of wants, right? If there is a double coincidence of wants, of course, we wouldn't necessarily need money or a medium of exchange to trade. We could just use barter, right? So there should be a lack of double coincidence of wants. That by itself is not enough, right? To give value to a medium of exchange. We will need other frictions, in particular limited commitment. So it should be the case that we cannot just agree on some outcomes. So for example, it might be that I meet with Bruno. Bruno has something I like, but I don't have anything he likes. But then Lucas has something that he likes, and I have something that Lucas likes, and so on and so forth. So even if we don't have a double coincidence of, even if there is a lack of double coincidence of wants in each separate meeting, as long as we could commit to trade, right? We could still avoid using a medium of exchange to implement trade, right? So it should be the case that there are some frictions that limit commitment. So we shouldn't be able to commit. And finally, also some information frictions. The role of information frictions, we'll see, differs depending on whether we're focusing on an infinite horizon economy or on a finite horizon economy. So for infinite horizon economies, the role of information frictions is basically to rule out fork type theorems kind of arguments, which basically would imply that you could support potentially good outcomes even in the absence of money. For finite horizon, instead, these information frictions we'll see are important to circumvent the backward induction argument, right? Because typically the intuition is that money cannot be valued in finite horizon economies by because of backward induction arguments. Since if we are in the last period, I would not give up anything. I would not give up something of value for fiat money because there is no future, right? I cannot spend it. So why would I give up something of value for something that is worth nothing, right? It's worthless. So in period T, money wouldn't have value. Or when you go in period T-1, agents would anticipate that, right? And would not use money and so on and so forth. So, but backward induction, money would not be valued. But we'll see in the illustration today that you can impose some frictions, information frictions, that basically allow the researcher to circumvent this backward induction argument. So why did we use here an experimental approach? As I mentioned when I was describing briefly the literature, we kind of know by, there are several studies show that money can help. And in these studies typically implement, with the exception of Davis et al., they basically implement theoretical frameworks where money is not essential. Basically, money does not expand the set of equilibrium outcome. And in these studies, people find that indeed the money is valued still, right? And people find it easier to coordinate on monetary equilibrium than to coordinate on a gift exchange equilibrium. This leaves the door open also to the question, okay, why is it that subjects use money? Is coordination a monetary equilibrium, or is it maybe that just they use money for non-strategic reasons, just use money automatically, and so on and so forth. So in this paper, I'm going to show you that the experiment will allow us to determine whether it matters that money is essential or not, and whether subjects use money just automatically, no matter whether it can be supported or not as an equilibrium outcome. When we see it more in a few slides, the framework as well as the results. So we know that money can help when it's not essential. We also know that money can be essential, but not help. In what sense? Well, typically, when we introduce money, right, there are multiple equilibria. And again, in this case, theory doesn't provide guidance on which equilibrium is more likely to rise. So it could be possible that indeed the subjects, despite there being a monetary equilibrium, subjects would find difficult to coordinate on the monetary equilibrium. So here, again, we ask the question of whether subjects manage to coordinate on the monetary equilibrium, and also we implement, we'll see, suggestions on monetary strategy with the idea of understanding whether suggestions would help coordination. In terms of theoretical framework, here we consider a finite horizon model with some information frictions. The model is based on a nice paper by Kovanok and Derry, Fiat Exchange in Finite Economies, actually, is the title of the paper. And this is a nice paper because indeed it challenges the view that you need an infinite horizon economy in order for money to be valued. And what we do, we implement basically two versions, right, of two versions of the economy. One where subjects know their position, so they will know whether they are the last in the economy, where it's the last period, right, and they are the last trading in the economy. And another one where, and in this environment, we'll see that by backward induction, one can show that money cannot be valued. And then what we did, we implemented a version where the position instead is unknown. And so now, and I'm going to give you some details, now subjects in the lab, agents in the model, do not know whether they are the last or not. And in this case, we see that the backward induction is circumvented. Backward induction argument is circumvented, and one can show that money can be valued and is essential. In addition of looking at these two different frameworks, we also explored the impact of suggestions on coordination. And that's the reason why we decided to look at suggestion is, as I mentioned, in the model where the position is unknown and there is a monetary equilibrium, there are also other equilibria. There is autarky, as a pure study monetary equilibrium, mixed strategy monetary equilibrium, right? So there are other equilibria. So we decided to introduce a suggestion to see whether it would improve potentially coordination on the monetary equilibrium. And this was in the spirit of a mediator of Meyerson, that is a person or machine that can help the players communicate and share information. Now, if you have been exposed ever to experiments, maybe you might be aware of this problem, but even if you're not, if you think a little bit about it, you would be concerned. Experimentalists are a bit wary of providing suggestions because they think, okay, you tell the subjects what to do, then if you observe something that confirms, right, or that is aligned, right, with the suggestion, it's probably just because they follow what you do, right? We have this authority, according to some, like we could be perceived as having some authority as experimentalists. And this issue is called actually experimental demand effect. So to address that, we actually provide this suggestion, even when it's not an equilibrium and it's not incentive compatible, so as to distinguish whether subjects follow it indiscriminately or blindly, right? Or indeed they follow it when it is incentive compatible or not. Finally, we also use the social value orientation and exit surveys to investigate anomalies. So we knew from previous studies that sometimes subjects produce where it's strictly dominant not to produce. So we also designed some surveys to better understand the source of this type of behavior. In terms of main findings, before we move into the design and more details on the theory and also, again, the principles we followed in implementing the experiment, we do find overall results that are broadly consistent with theory. Indeed, money significantly increases output when it's essential. We also find that subjects tend to use money for strategic reasons. Indeed, the usage of money is significantly higher when it is incentive compatible to use money. We also find that the recommendation helps more when following it is incentive compatible, when it is part of an equilibrium. And we shed light also on some of the anomalies, as I was mentioning. We do find that sometimes money is accepted. So even though, broadly speaking, results are consistent with the theory, there are some departures. And sometimes money is accepted when it's not incentive compatible, and exit surveys suggest this is due to social preferences and confusion. So let me jump into the theoretical framework. And here the principle that we used is this Occam's razor, or KISS, which stands for keep it simple, stupid. I learned this from colleagues, nothing sexual here, okay, just an acronym, keep it simple, stupid. So again, for this particular game, it's gonna be relatively, it took us quite some thought to keep it simple, stupid, but it's in a sense easier than maybe some of these other dynamic environments. But the dynamic environments or the more complex macroeconomic models, I think they're still, they can still be implemented. Again, I as well as others, like I've done work on it. But for that, the acronym, a little bit of a joke that I invented is actually KICK, okay? Which means keep, which stands for keep it clear, kiddo. Okay, so basically what I'm trying to say here, you should try to keep it as simple as possible. But even when the environment is a bit more complex, use Occam's razor, try to go to the bare essence of the model, and you can start by implementing that. And it might take time to figure out, because again, the theory doesn't tell us necessarily how to implement the theory, right? So there are some things that it is silent about, and we, as we design the experiment, we need to think, right, how to implement specific features of the model. So going back now here to this game, In this theoretical framework, there are 3 agents with equal chance of being player 1, 2, or 3 ex ante, and an indivisible good. Okay, so why 3? Again, the minimum number of people that would make the theory work. They participate in 2 sequential meetings. First, player 1 meets with 2, and then player 2 meets with 3. And the earlier player is the consumer, and the other is the producer. So in the meeting between player 1 and 2, 2 can produce for 1, but not vice versa. In the meeting between 2 and 3, 3 can produce for 2, but not vice versa. Okay, so this is again to capture the absence of double coincidence of wants, which is one of the ingredients for money to be valued. Agents can only observe what happens in their meeting. Utility from consumption is U, and this utility from production is C. We're going to work here with 2 information structures. So there is model N, where everyone knows their role. So player 1 knows that he's player 1, 2 knows he's player 2, and 3 knows he's player 3 at the time of the decision. So for example, player 3 would know that he is the last, right, in the queue in model N. In model M, however, only player 1 knows his role, and the other 2 only know that they're not player 1, and they could be with equal probability player 2 or player 3. So what happens now in this model? Well, if there is no money, it's easy to see that autarky is the only equilibrium, no matter whether you are in model N or in model M, right? In model N, anyway, producing is costly, right? Producing, in both models actually, producing is costly, and it does not affect the probability that somebody can produce for you. Okay, so autarky is the only equilibrium. What happens if now we introduce money? So what does it mean we introduce money? Here we endow player 1 with an indivisible token, which has no intrinsic value. And this would, by the way, when we implemented this in the lab, we made it clear, subject knew that this token was not, couldn't be converted into dollars. Okay, so and we stressed it also in the instructions as well as in the quiz. So what are the action choices here? For meeting 1, player 1 decides whether to offer the token to player 2 in exchange for production. Player 2 sees the offer and decides whether to produce. In meeting 2, if player 2 acquired the token from the previous meeting, he decides whether to offer it to player 3 or not, right? And then player 3 sees the offer and decides whether to produce. So these type of actions are the same in both models, but what's different is that player 2, 3 know their role in model N, but not in model M. So if I am, for example, in model M, and I see that somebody has offered me a token, I do not know if this is coming from player 1, who is offering me the token, or it's coming from player 2. So it turns out, I don't know if I'm player 2, so the offer is coming from player 1, or if I'm player 3, and the offer is coming from player 2, who traded with player 1, and is offering the token to me. So what happens now in this type of environment? Well, in model N, the unique equilibrium is also autarky. Okay, it remains autarky. The fact that we introduced this token, and that the action set expanded doesn't imply that doesn't add new equilibrium outcomes. It's easy to see, again, by the backward induction logic, is very easy to see that if you're player 3 and you see an offer, for example, you would see the token being offered, you will not produce, right? That's strictly dominant strategy not to produce because it costs you C points, right? Costs you C, and the token has no intrinsic value. And so player 2 can anticipate that they will not produce for the token, and so the only equilibrium is autarky. So what happens in model M, however? In model M, there is also a monetary equilibrium as long as the utility from consumption is sufficiently large. To see this, let's think about the monetary strategy. So what would the monetary strategy prescribe here? The monetary strategy would prescribe to player 1 to offer the token, and player 2 and 3 to produce only if they are offered the token and transfer it to the next player if they are in a position of transferring the token. So, so here it's easy to see that for player 1, it's a weakly dominant strategy to offer the token. And then for player 2, 3, what's their expected payoff if they play the monetary strategy? Well, with probability 1/2, it turns out that I am player 2. So I produce for the token, so I get -C. I produce for player 1, I got the token, I got -C. Then I offer the token to player 3, he produces for me, because he's playing the monetary strategy, right? And I get U. So with probability 1/2, I'm player 2, I get a payoff of U minus C. With probability 1/2, it turns out I'm player 3, in which case I only lose, I lose -C. As long as the expected payoff from playing the monetary strategy is greater than the payoff for playing the non-monetary strategy, there is no incentive to do. So again, here we can see that it's possible to add, basically we added some equilibria. And in particular, an equilibrium, here we're seeing an equilibrium where money is used in exchange, right? And it's where production takes place. And so welfare, overall welfare is higher. So is that clear about the theoretical frameworks? Quite simple. There are, again, just these two models, model N, where the agents know their position, and introducing a token or a medium of exchange here doesn't affect the equilibrium outcomes, right? Autarky is the whole equilibrium. In the other, where there is uncertainty in the position, so I don't know if I am going to be last or not. This could be seen a bit of a truncated version of an overlapping generation model. So money could have value, okay? So these are the two main frameworks which we implement in the lab. Okay, so if there are no questions, I'll go to the experimental design. So here we had the treatment variable is the variable that we change one at a time, right? So here we change one at a time. And the treatment variables were basically whether we were model M framework or model N framework, whether there was money or not, and whether there was the suggestion, okay, the monetary strategy or production strategy suggestion. Okay. So these were the three main treatment variables we focused on, with the goal of answering the following question. So is there more production with money than without it in model M? So model M is the model where there is a monetary equilibrium. And the idea here is, again, to going to the spirit that, you know, if there is money, is not necessarily welfare improving, right? Because there are multiple equilibria, but we don't know if they coordinate on the good equilibrium. So the question here is, again, to compare environments, model M with and without money, okay? So M0 with M1, without money, to understand whether there is more production with money when there are multiple equilibria compared to the case where there is only one equilibrium, the autarkic equilibrium. Oh, sorry. So the second question is with money. So now take two environments with money, in particular model M with money and model N with money. Is it the case that there is more production in model M with money, where there are multiple equilibria, compared to the case compared to model N with money, where there is again only the autarkic equilibrium? And finally, the last two questions have to do with the suggestion, and the question whether suggestions have a bigger impact on production in model M with money than without it, or in model M with money than in model N with money. So the idea here is, again, to look at suggestions when they are in equilibrium, or in model M with money they are in equilibrium, and contrast to the impact of suggestions with the impact of suggestion in environments where it's not an equilibrium to follow the suggestion. And that's the case in model M without money and in model N with money. Again, it's not an equilibrium to use to follow the suggestion. So why did we do that both in model M without money and in model N with money? Basically, in addition to taking care, right, of the experimental demand effects, it's also, we did that because in model N with money, when we're making a suggestion, of the monetary strategy. Not only it is not an equilibrium, but it is also not ex-ante Pareto superior, okay? Because player 3, if he follows the suggestion, is always going to be stuck with -3. On the other hand, in model M, without money, the suggestion, even though it's not an equilibrium, the suggestion would be Pareto, ex-ante Pareto or superior to autarky. So we wanted to account for both potential, for these different situations. Basically, with the question 3, we can check whether, even if it's not an equilibrium, they would follow it just because they are ex-ante better off. They could even follow just because they are ex-ante better off, even though it's not an equilibrium. So overall here, the main principle that I would, we typically follow in experimental economics, and especially it's an advantage of experimental method, laboratory methods, is to change one thing at a time. Okay, so here again, we only change whether they're in model M or N, keeping constant the other 2 features, money or suggestion, or if we keep fixed, right, the model, and we see what the impact of money versus no money, and so on and so forth. So we're changing one thing at a time to isolate the causal impact on outcomes. And again, this is an advantage of experimental laboratory methods, where we can be spoiled and change indeed only one thing at a time. So the principle, here. So the other important aspects of the design here, we wanted to implement this game, right? The game consists of the two-period game. It's a sequential game. First, player 1 meets with 2, and then 2 with 3. What we did is we had subjects play the game 15 times, okay? To allow subjects to gain experience, because if you implement it only once, there would be a lot of noise in the data, because subjects might not be familiar with the particular game, right? So they didn't have a chance, right, to gain experience with the game. So we had, and this is typical again in experimental economics, even when you want to test the prediction of a one-shot game, to have subjects play the game multiple times. So we had subjects playing 15 times. Of course, since we do that, like, you open the door to other potentially confounding factors. For example, it could be that you could generate repeated game effects. Okay, and of course, if we were taking our one-shot game and make it repeated, there would be different predictions than than if it's were one shot. So to mitigate these repeated game effects, so basically to have a closer map between the experimental implementation and the model, we also had random grouping in each game. We were forming groups of 3 people, but they were not staying constant over the 15 games. They were randomly formed. And also we fixed role. So in model M treatments, the role was fixed indeed for all 15 rounds. In model M treatments, by design, we couldn't keep the role fixed, right? Because it relies on player 2 and 3 not knowing whether they're 2 or 3. We only kept then player 1, the position, only for player 1, the position fixed, and the rest were randomly assigned. Regarding the suggestion, this is not correct. Okay. So the suggestion, let me see, it's going to the wrong. The suggestion. Okay, so regarding the suggestion, we had both in the instructions, the suggestion treatment, we had both in the instructions and also in the quiz, right? And in the screen, in the decision screen, the following statement: a suggestion, each player in a group may consider making the following choices. Whenever you have the token, transfer it to the next player, if there is one. Produce only if you're offered the token. This is simply a suggestion, feel free to follow it or not. This was the phrasing of the suggestion in monetary treatment. The wording in treatments without money instead was a suggestion: if you're not player 1, you may consider choosing to produce. Again, this is simply a suggestion, feel free to follow it or not. Okay, so these were the things. And in the quiz, we were making sure that they would understand that it was not a requirement to follow the suggestion, that they were free, right, to follow it or not. In terms of procedures, sorry, this going something wrong with the file. Yeah. So procedures, I'm going to tell you in words because I wouldn't want that it goes right. So we had that they were first participating in these 15 games. Then there was this first exit survey where we were asking them questions about considerations that might have played a role in their decision. Again, the idea here was to better understand their thought process when making decisions. Then they were doing a short demographic survey where we asked for gender, field of study, fluency in language, and there was another thing. Okay, but anyway, we try to control for things that that other experiments showed they might play a role, like gender, right? So we wanted to control, for example, for gender. And then finally, they were participating in the social value orientation task, which was a task to, designed, which is used also by experimentalists to control for other regarding preferences. Other procedures, yeah.
So I have a kind of two questions in one, but I'll ask one at a time. So first, like, in terms of like general principles that we have to keep in mind, one was like to make it clear, and then like I think that's extend to repeating rounds so people kind of learn to try to make sure people understand. Is there anything else that we, I know we did, we did.
I'm gonna show you now. I'm gonna tell you.
And the second one was so just in more like, is there, and the second one was the repeated game effect. And then I was like, what are the other things that if you are designing an experiment, you have to keep in mind that you can somehow mess up your results? So people,
I mean, it's hard to tell you like a one size fits all kind of stuff, because it might depend on the experiment. There are some things that we learn after we do the experiments. And this is again natural because the theory doesn't tell us, right, necessarily. I mean, of course, the theory would tell us have people played just once, right? Maybe you invite them, they play once the prisoner dilemma, they leave, or they'll play once, whatever, coordination. But that's not de facto good, because there is going to be a lot of noise there, right? So your data is not going to be that informative, because
I guess if you want to do that, then we need to have a lot of experiments to kind of.
Either you will need to have a huge sample, right? Or depending on how many people are also confused or not, it's typically advisable to have multiple. But you would generate, there is a potential of generating repeated game effect. So people, what they did is to randomly match across rounds, so that I know that if I'm meeting you today, the probability that I meet you again is very small, right? So I treat every interaction as a new interaction, but at the same time, I learned a bit, right, about the game, right, how the payoffs are formed, right, all these things. Some people, in some cases, they have some practice rounds first, and then the actual play. Yes, I mean, these are choices that we made based also, by the way, on previous studies. Right, we learned a lot from your previous study, right, with Davis and others, right? We learned some features of the design that, because we observe different results. When I go through the result, I'm gonna discuss this. We observe in our paper different results than in your other paper by Davis, Korenok, Norman, Sultanum, and Wright, right? There is a paper that implements also finite horizon economies. And we learned a lot also from that, right? So some of those things are not obvious. Again, it's something that you learn by doing experiments, and again, it's not a universal, something that maybe works in one area might not work in others. So it's not.
It's a lot of.
I mean, in terms of big principles, I'm going to tell you some that we follow that everybody kind of follows. Okay.
Okay.
But yes, just to say here, the main thing I want to highlight here is that they were gaining these 3 points from consumption, right? And they were losing 1 point from production. They were given also an initial endowment, 3 rounds randomly selected for payments, and then these were the conversion rates. So every point was $2. There was a show-up payment, and average earnings were 19. So notice here, what I want to highlight here is that the points that they were earning was linked to their performance in the game. Okay, so, and then these were converted then into dollars, into money, into real money. So why did we use money? Why did we use money? Well, this is actually one of the principles. This is a nice paper by Vernon Smith establishing principles that we follow, the precepts of experimental economics. Well, the idea is, in general, you should use, the principle is monotonicity or non-satiation. Here, you should use a reward medium that subjects like, right? So subjects must prefer higher amounts to lower amounts. And I mean, money is typically the reward medium we use because everybody kind of likes money. It's kind of more uniform, right, than other medium of exchange. Of course, it's not universal. For example, people who do experiments with children use toys. Okay, so you have to find, but I mean, in general, for adults, the money is the typical reward medium with the idea of using this monotonicity, right? You want to motivate. This is called induced value theory in the sense that we would like to motivate and align as much as possible the incentives in the model with the incentives in the lab, right? And in the behavior, right, of subjects. The other important principle, that's why I was pointing out that their earnings are linked to their performance, is the saliency. That is, the reward earned by subjects must depend on her choices, and possibly the ones of other participants as specified by the experiment. So the idea is not just to have a flat payment, right? Okay, you just show up, whatever you do, you get $15. No, I mean, we should do our best to implement the incentives in the model, right? The incentive of the model in the lab. And that's how we typically do. We link earnings to their performance. And performance is determined depending on the model, right? Whatever the payoff function of the model is. The last one is dominance. In a sense, this is most difficult, right? To be sure that you implemented it correctly, right? This is basically saying that the reward structure should dominate any subjective cost associated with participations in the activities on an experiment. That is, subject's utility should be mainly affected by the reward medium rather than other factors like boredom, experimental demand effects, I don't know, some joy of winning, some other things that are outside of the model. That's why we try to do also to use this Occam's razor to make it as simple as possible, as cognitively easy as possible, also for subjects to get the incentives and so on and so forth. So these are principles that people typically universally follow. And again, this is typical of experimental economics, not so much for survey experiments, for example. You not have that there is a right or wrong answer. So it's also difficult to provide incentives related to performance, right? So saliency would be difficult. So, but they typically, there is a non-satiation in the sense that there are sometimes, at least in the experiments, some monetary incentives, even though they're fixed, right? They might, yeah, they're fixed. For service, we typically give a fixed incentive. Okay, so then are there any other questions? So again, in terms of design, for us, what we try to do is to make it as simple as possible. And this already came from the model, right? We were choosing the simplest possible framework. And we try to avoid repeated game effects and keep it as similar as possible between the two frameworks. So we kept both the sequential, feature, and here we only kept, by design, we only could keep player one's fixed role. And so we try to implement the two models as closely as possible, again, to avoid confounds and have a cleaner comparison. Okay, so there are no questions. Let me go through the experimental results. So these reports, this picture, in a sense, it's showing one of the main messages of the paper. And what does it do? The left panel pulls treatments where the monetary equilibrium exists. This would be basically model M. So the first index is whether it's model M or not. The second index is whether there is money or not. And the last index is whether there is a suggestion or not. So here we're looking at model M with money, with or without suggestion. These were the only treatments where a monetary equilibrium existed. And on the right panel, instead, we report average production rates for the treatments where an equilibrium did not exist, a monetary equilibrium, only autarky. So two features stand out here. Production rates are higher when a monetary equilibrium exists, tend to be higher, right? When a monetary equilibrium exists compared to when the only equilibrium is autarky. And also they're relatively stable compared to the case where equilibrium is autarky, where they kind of start high, but then with experience, and again, here we see how experience is important as well, they decrease until roughly reaching 20%. Going into the questions now, remember we had those 4 questions. Is there more production with money than without money in model M? And the answer is yes. And again, illustrated, the left panel is illustrating the treatment without suggestion. So model M with money and without money and no suggestion, and model M with money versus model M with no money with suggestion. And as you can see, production rates tend to be always higher. The blue line is above the green line in both cases, no matter whether there is suggestion or not. So indeed, we find that on average, money increases production by more than 20% and persists across rounds. And here, I mean, I'm not gonna go this, here there is basically, we provide some Mann-Whitney tests. These are some non-parametric tests that experimentalists use. And this result is not super surprising in the sense that other people, other researchers have observed in the laboratory that money increases production. Then basically when there is money in the environment, there is more production than when there is no money. And this was observed by Cameron, Casari, and Duffy Puzzello in environments where actually money is not essential, in the sense that in their environment was not expanding the set of incentive feasible allocation. But curiously, this is not consistent with Davis et al., who also implemented a finite horizon economies, but who found that that there was no significant difference, I think, here between the two environments. Okay, so yeah, we do find here. And we suspect, basically, Davis et al. Found the results that money tends to help actually more in model N than model M. But again, we suspect that some of the design features might have affected the results. And again, these are things that ex ante are not obvious, but they emerge more ex post. And they deserve also further, because we departed in several ways from Davis et al. And they deserve further investigation. So let me tell you about the second result. The second result in some sense is more novel and interesting, I think. The question here was, with money, is there more production in model M than in model N? And indeed, we find here that that's the case. So in model N, when it's not an equilibrium to use money, production rates are lower than in model N, regardless of whether we have a suggestion or not. So overall, indeed, we find that that it is important that money is essential in order for it to be valued. And why is this an important message? Because this shows that subjects do not mechanically use money. Okay, so you just endow them with a token, intrinsically worthless object. They do not just automatically use it. And the strategic considerations are important. It's important that it is incentive compatible to use it. And again, this is something that in Model N, with suggestion especially, it happened with experience helps, right, to understand that when it is incentive compatible to use money or not. So actually for us, indeed, it was crucial. But I mean, it's true for many other experiments in repeated games, prisoner dilemma games. It's also very important that subjects repeat the game over time in terms of learning. So finally, regarding the impact of suggestions, the left panel shows average production rates where there was suggestion compared to the case where there was no suggestion in Model M with money, where it was incentive compatible to follow the suggestion. And we find any impact. It's not a huge impact, but it is significant, and it's roughly leading to 10 percentage points higher production. What happens in the other two cases where instead, the right panels, where instead it is not an equilibrium to follow the suggestion? Well, in Model N with money, as you can see, actually at the beginning, the suggestion was making an impact. So they were producing more. So if we just focus on the very first game, we had roughly 70% production rates against 35%, let's say. Right? So at the beginning, there was quite a big impact of suggestions. But then as subjects gain experience with the game, they also learn to ignore the suggestion. You can see that here, after game 5, and especially after game 10, there were not that much, no significant differences, right, between production rates, depending on whether there was the suggestion or not. And similarly for Model M without money, where again, it was not incentive compatible to follow the suggestion to produce, with experience, subjects learn to ignore the suggestions. And by the last 5 rounds, there is no significant difference. So overall, our results are consistent with the theory. We do observe, though, some deviations from the theory. For example, player 3, Model N produces, Model N with money, even though it's always player 3 is gonna only lose money, but they also learn over time. We'll see production by player 3 actually decreases quite dramatically over time. And, but it is a bit of a puzzle, right? A departure. And player 2 and 3, Model M without money also produce. So we did the exit surveys. We basically looked also at the social value orientation, because it's possible that player 3 produces because he cares about the other player and it generates some, it increases, right, welfare, overall welfare. But we used the social value orientation and we didn't find that it improved our understanding of this departure. However, exit surveys, they were quite valuable, and they basically, we basically learned that in general, strategic consideration tend to dominate, but when there are some departures, they seem to be attributable to social preferences, confusion, and repeated game consideration. For example, for Model N, this is the last thing I'm gonna show you here. You see, most of the people say, player 3s, say that they were never in the situation of producing. But for those who did produce, we have that some people mentioned that they made a mistake, or they did it to help the other player. So this would be some other regarding preferences. Some confusion, because some people said that did it to increase the chance of trading it for the good with another player. or the token for the sake of it. So it looks like that there was a mix of confusion and other regarding references. And again, we have some more details on other, for the other frameworks, motivation. Also in the paper, we discuss production meeting 1 versus meeting 2, but what I want to highlight here, indeed, if you look at model N, for player 3, they learn very quickly to stop to produce, right? For player 2, it takes a bit longer. So since I'm almost out of time, let me just conclude here by saying that here we designed an experiment to study whether money is essential. We found that introducing money significantly increases output when it is essential. The use of money is higher when incentive compatible than when it's not incentive compatible. So this suggests that subjects use money for strategic reasons. We also find recommendations help when incentive compatible, but not otherwise. And whenever we observe departures, for example, money sometimes is accepted when it's not incentive compatible. This is due mainly to social preferences and confusion. Finally, a nice feature also of experiments is that in some cases, you answer some questions and some more arise, right? And we think that this framework, since it's very simple framework, could be also extended to understand, for example, to contrast communication. Right now we use suggestion, right? But we can think about allowing subjects to communicate and see whether they would figure out the monetary strategy and how they would discuss incentive to produce and so on and so forth. Thinking about the chain length, memory versus money, the fragility of monetary equilibrium, for example, right now they just play with money. We could think about, or without money, we could think about having them play without money first and then introducing money and see, or start with money and remove money and so on and so forth and see how, or for example, even either model M with money and then switching to model N with money to see how, right, to think more about the emergence and sustainability of monetary arrangements. So I think I'm done. So thank you. Again, I hope I conveyed to you that this is just a tool, as many other tools we use, theory or empirical methods, that we should use in a complementary way, rather than in a competing way, and trying to figure out what's the best tool depending on the question you have in mind. So if you have any questions, feel free to contact me. This is my email address. And yeah, thank you for listening.
Thank you, Daniela, for coming. I definitely learned a lot, even though I'm co-authoring the paper. It's always good to have someone that's specialist in the field and can provide us a lot of insights about not only general view, but also how to do things the right way. And we are going to have this video posted on YouTube the next day or so. But thank you again. And if you have any questions about our lecture series, please feel free to email SaMMF. You can find the email on our website. Thank you. Bye.